Good morning, everyone. Very good morning. Good morning, Janvi, Yanam. Just give me 30 seconds, some more. Okay. Okay. So very good morning. I hope you all are good and you all are taking care of your health. Please take care of your health because weather is changing and there is high chance that you can fall ill. है ना? तो take care करो और साथ साथ पढ़ाई भी करो चलो so let's start today today in the class what we are going to do we are going to solve questions from magnetism and matter okay so I will start with the question itself and what I will do in between through questions or while we will solve the question we will learn the concept okay chalo so the very first question is there on your screen then I hope it is visible to everybody if not let me know through the chat section but if it is visible take your 1.5 minute of your time or 2 minute I'm giving chalo 2 minute but this much time you don't require if you know the thing again I'm giving you 2 minutes read the question carefully and try solve वॉल्यूम नहीं है मेरी आवाज नहीं आ रही others please am I not audible या फिर आवाज धीरे आ रही है जेबी भावनगर yes very good please यार वॉल्यूम कम है क्या बताओ कोई भी am I not audible JNB from Simoga, I got like कि I'm not audible. Volume is low. Is it there for everyone? कोई और बता दो. No ma'am. मतलब audible हूँ. हाँ चलो ठीक है. Others please let me know the answer. I have taught such things also like in weekdays classes है ना JNB Jamnagar highest net magnetic dipole moment पूछ रहा है and the answer that you have given me will be true for minimum ठीक है आप क्वेश्चन को ध्यान से पढ़ो यहाँ पे हाईएस्ट पूछ रहा है ठीक है क्वेश्चन इज व्हाट व्हिच configuration has highest net magnetic dipole moment it is asking for highest one Janvi Yanam let me know the answer okay let me tell you how to solve this question so question is what जैसे देख लो अब if there is a bar magnet in the previous class also or in weekdays classes I taught if there is a bar magnet एक second okay so if there is a bar magnet of something like this if this is the south pole this is the north pole so for bar magnet we can define dipole moment, right? Magnetic dipole moment, just like we defined electric dipole moment for pair of charges, है ना? So there was a minus q charge and then there was a plus q charge, right? Separated by certain separation 2a. And in that case, electric dipole moment value was how much? 2q into a value if I talk about. And if I talk about the direction, then direction of electric dipole moment was from negative to positive charge, okay? So for those who don't know, उनके लिए मैं discuss कर रही हूँ. So south pole को we consider as negative magnetic charge. This is a negative magnetic charge, ठीक है? And this north pole is what? This is positive magnetic charge, ठीक है? And what is the value of this charge? That is termed as pole strength. So in the question, if question is of that sort, then it will be given pole strength of south pole is this, north pole is this. That is denoted as small n. So this is minus small n and this is plus small n. Okay, done. So dipole moment here we write as magnetic dipole moment ka magnitude is written as what? Pole strength into distance between south and north pole. If it is 2a, then it will be m into 2a. Direction will be from south to north pole. Okay, this is this. Now, in the question, what is given? In the question, you can see there are two magnets given, है ना? एक का अगर मैं first question पे जाऊं तो देखो यहाँ पे दो magnet है and they are at 90 degree to each other. सबसे पहले what you should do is you should write individual dipole moment for these two magnets. So what will be individual dipoles direction first you deal with. तो direction क्या होगा? First south से north होता है direction. So for this is and for this is, है ना? So for first question we have two dipoles, one in this direction and another is this direction. Suppose कर लो one's dipole moment is m1 and another one is m2. But they are of same length and same width, तो दोनों का value same ही होगा. But still मैंने 2 लिया क्योंकि direction different है. M1 and M2. So what will be M net? Net dipole moment क्या होगा? Now this is a question of vector. दो vector है 90 degree पे, solve it. So what will be the answer? M1 square plus M2 square plus 2M1 M2 cos 90. Cos 90 is how much? 0. So what will be the answer here? It will be M1 square plus M2 square. Now come to the second thing, second option. If you go to the second option here, one dipole's direction is in this and another's dipole direction is in this. Their magnitude is same, है ना? There are each magnet has magnetic dipole moment m. Question में दिया हुआ है. Their dipoles have equal magnitude, so their directions are opposite. Magnitude is same. So here the net dipole moment will become how much? M net will become 0. है ना? Similarly, come here. One dipole direction is this, another is this. What will be the magnitude? Their angle is how much? 30 degree. So magnitude will be m1 square plus m2 square plus 2m1 m2 cos 30, right? And for this it will become cos 60. So सबसे ज्यादा कब होगा? M net will be highest for the pair where theta is where value of cos theta is highest, and value of cos theta will be more when theta is less. So in which case theta is less? Here theta is 90 degree, here theta is 180 degree, and here theta is 30, and here theta is 60. So in which case angle is less? It is here 30 degree. So answer will be what? C. Okay. So one correct answer I got also. Anyone having any doubt in understanding this? है तो बता दो. किसी को कोई डाउट है? नहीं है, I guess. चलो. So if not, then do this question again. Same sort of question it is. I want answers from everyone. So I'm giving you 1.5 minutes. Let me know what is the answer. JNV, Simoga, Rajkot, Jamnagar, Jalgaon, Bhavnagar. चलो बताओ, JNV, Yanam. What is the meaning of Yanam? If anyone can tell me when you have time, है ना? अभी क्वेश्चन करो. This is a bar magnet, right? We have simply bent it to look like an arc, and this arc is making an angle of 60 degrees at the center, right? You have to tell, जैसे when this magnetic dipole is in this shape, if it is a straight, then suppose this is south, this is north, then magnetic dipole moment will be what? This distance, if you consider as L, that is given in the question, L length ka hai. So if it is L, its pole strength is suppose small m. So magnetic dipole moment ka jo magnitude hoga, that is ML, and that is given as equal to m in the question, hai na? And its direction will be from south to north pole, right? Finally, when we are bending it, what will be the dipole moment? So again, dipole moment will be m into length between south pole and north pole, है ना? Dipole moment कैसे निकालते हैं? Pole strength into distance between south and north pole. If we are bending it, distance between south and north pole will decrease, and it will be this now. अब distance ये होगा ना? So now you let me know the answer. I've given you enough hint. Now let me know what is the answer. Yes, come on. You just need to calculate this distance. Length of arc is given. Length of a bar magnet is L. A bar magnet of length L दिया हुआ है ना? So length of arc is given. That is how much? L. Calculate this distance fast. सो रहे हो सब? Or have you taken heavy breakfast? What was the case? कोई कुछ बोल ही नहीं रहा, आंसर भी नहीं बता रहे तुम लोग. This should not happen. JNV, भावनगर, जलगांव, जामनगर, राजकोट. जल्दी से बताओ क्या आ रहा है आंसर सबका. अब मैं सबका नाम कितनी बार लूं? You can do it. नहीं करोगे मैं आगे नहीं बढ़ने वाली हूँ. You just need to calculate this length. Anyone who got the value of this length, let me know that itself. Forget about the answer. Let me know the length of this thing. New length, new distance between south and north pole. कितना आ रहा है? JNV, Jamnagar. नहीं, अनफॉर्चुनेटली इट्स रॉन्ग। क्या कर रहे हो तुम लोग सीरियसली? कुछ नहीं करना यहाँ पे। ये डिस्टेंस, दिस डिस्टेंस विल बी हाउ मच? JNV भावनगर, यस, दैट्स ट्रू। सोनीतपुर, it's not correct actually, but you tried, that is good. कैसे निकालोगे? ये डिस्टेंस ही तो निकालना है। इफ यू लुक एट दिस ट्रायंगल, ये जो ट्रायंगल है इसको ध्यान से देखो, दिस इज रेडियस, दिस इज आल्सो रेडियस, सो दिस टू साइड्स आर इक्वल। if these two sides are equal, these two angles will also be equal, है ना? This angle is 60 degree, sum of these two angles should be 180 degree, क्योंकि sum of all these three angles is how much? 180. So जैसे 2 थीटा प्लस 60, इतना करने की जरूरत नहीं होनी चाहिए ना क्लास में, और इन क्लास 12 2 theta is equal to how much? 120. Theta is equal to how much? 60 degree. So this is an equilateral triangle. If this is an equilateral triangle, all its side will be equal, यानी कि new distance between south and north pole is equal to the radius, है ना? What will be the value of radius? Now we can calculate radius very easily. You see here, this is an arc of length L. If you have studied that if there is an arc of length L, and if this is forming an angle theta at the center, this is the radius, this is L, then L is equal to how much? R theta. This you already know, right? This is a very basic mathematics. तो यहाँ पे क्या लिखोगे? L equal to R, theta कितना है? Pi by 3. So R is equal to 3L by pi. So R is equal to this new dipole moment. न्यू डाइपोल मोमेंट क्या होगा तुम्हारा? पोल स्ट्रेंथ इनटू दिस लेंथ, दैट इज, क्योंकि न्यू डिस्टेंस बिटवीन साउथ एंड नॉर्थ पोल इज इक्वल टू रेडियस, सो 3L by 2 pi. So you can see here ML into 3 by 2 pi, and ML is equal to how much? This is equal to capital M given in the question. So this is 3M by 2 pi. So correct answer will be what? Correct answer will be 3M by 2 pi. So this is the correct answer. Any doubt anyone? देखो जिसका नहीं हो रहा था, कोई भी डाउट है प्लीज पूछ लिया करो. You are free to ask doubt. Teachers are in the class for what? Not just for writing things on the board, not just for giving you questions and then solving it. No, they are largely here for solving your doubts, your queries. ठीक है? तो प्लीज मुझे बता दिया करो इफ यू हैव एनी डाउट, एनी प्रॉब्लम इन अंडरस्टैंड. ठीक है? एनी डाउट अगेन आई एम आस्किंग. चलो ठीक है. Now answer this question. I'm giving you just 1 minute. Let me know what will be the answer. ठीक है? How? JNV Bhavnagar, how you are getting this? This should not happen in any condition. JNV Rajkot, कैसे होगा ये? You also, punish yourself for such options. This is a very basic question, JNV Sonitpur. Yes. Only one answer correct. I expected everyone to be correct this time. There on YouTube, everyone is silent. Send me answers, please. What the question is? Question क्या है? Which of the field pattern given in the figure is valid for electric field as well as for magnetic field? Which is true for both? That is the question. So this is what? This field lines is going out from certain point. So this field line must be a positive charge, right? Only positive charge. It can't be of a magnet. Again, here field lines are ending on a certain point. It must be of a negative charge. Again, only true for electric field. This is a closed field line. Closed field line is never true for closed field lines. Can't be E field. कभी भी नहीं हो सकता. Electric field never forms closed loop, right? That's a fact. It doesn't happen, and I've explained the reason also in the class. Now come to this thing. If you look at this, what you can see here, if you see dipole, minus Q plus Q. So if there are two charges, minus Q positive charge end on negative charge, something like that. Am I audible? Okay, so here it will go out like this, done, and some will end like this, done. So this is the field line for dipole, electric dipole, and also this can be field line for bar magnet, that is magnetic dipole. Magnets always exist as dipole, right? So this is true for both electric and magnetic field. So this is the only correct option. 1, 2, 3 you can easily neglect, right? This is a closed loop, not true for electric field line. This is of positive charge, this is of negative charge. So only this is the option, right? So correct option will be what? It will be D. I hope you got it. Now look at this question. Take your some 2 minutes of time and let me know the answer. Okay. So because in CBSE class you all must have studied these things. थोड़ा memory को jog करो. If you're not able to get it, I will explain definitely. But before that, jog your memory. Try to recall. Try to read the question and see which option will suit the best. You all have studied hysteresis curve. नो आंसर्स कमिंग, क्या हो गया? जेनवी सोनीतपुर, ओके, no, 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 it can't be. Okay, let me explain it actually. अगर आपने पढ़ा नहीं है, again no problem. जेनवी सिमोगा, जेनवी जामनगर, बहुत इनकरेक्ट। चलो ठीक है, देखते हैं। So देखो, if I want to explain it in the way that you can understand everything, तो मुझे जैसे सोलेनॉइड तुम सबने देखा होगा, दिस इज अ सोलेनॉइड, ठीक है। When we pass current through the solenoid, what happens? There is magnetic field inside it, है ना? And that magnetic field value is given as what? Mu naught Ni. So that changes with current. That changes with number of turns per unit length. But if the solenoid is once made, we can't change the small n, but we can change I by changing the source. Done. So as we will increase I, we will increase. That is going to happen. Suppose कर लो, I want to increase a magnetic field inside solenoid without increasing current. What I can do, I can keep a magnetic material inside the solenoid. इसका मतलब क्या हुआ कि सपोज कर लो एक मैग्नेटिक मटेरियल ले लो and just wrap the solenoid over it. In that case, what will happen? If you are going to pass current through it, then one magnetic field will be because of this current, and that value will be mu naught Ni, and another magnetic field will get generated, and that will be because of this magnetic material kept here. तो देखो, इसको भी अगर तुम्हें इजीली अभी समझना है, यू कैन अंडरस्टैंड इट बिकॉज आई हैव डिस्कस डाइपोल। मैंने क्लास में पढ़ाया था डाइलेक्ट्रिक पढ़ाया है ना। सो व्हेन वी प्लेस डाइलेक्ट्रिक इनसाइड इलेक्ट्रिक फील्ड, क्या होता है? वो एडिशनल इलेक्ट्रिक फील्ड जनरेट करता है, बट इट जनरेट्स इलेक्ट्रिक फील्ड इन द डायरेक्शन। नहीं, चलो यहाँ भी नहीं, इसको भी मत समझो, यहाँ से कंफ्यूज हो सकते हो। वेरी सिंपल थिंग दैट आई वांट टू मेक यू अंडरस्टैंड इज, इलेक्ट्रिक डाइपोल को ले लो आप ध्यान से, तो माइनस क्यू ले लो, प्लस क्यू ले लो, ठीक है, इलेक्ट्रिक डाइपोल। Now I have taught you कि if electric dipole is kept in an external field, what happens to it? What happens to it? Naturally, what will happen? The electric dipole direction from negative to positive will always try to remain in the direction of external electric. अगर हमारे पास डाइपोल है जो कि इस डायरेक्शन में था, सपोज at t equal to 0, and at t equal to 0, what I additionally did is I switched on an electric field in this direction. So ये डाइपोल क्या हो जाएगा? ये डाइपोल इस डायरेक्शन में रोटेट हो जाएगा इलेक्ट्रिक फील्ड के डायरेक्शन में, एंड इट विल गेट अलाइंड इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड। ऐसा क्यों होता है? ऐसा इसलिए होता है क्योंकि व्हेन डाइपोल इज इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, इट्स एनर्जी इज मिनिमम, क्योंकि पोटेंशियल एनर्जी का फॉर्मूला आप लोग पढ़े होंगे, माइनस पी डॉट ई। दिस इज मिनिमम व्हेन थीटा इज व्हाट? 0 डिग्री, दैट इज माइनस पी, राइट? सो मिनिमम होगा, और in nature everything wants to have lesser and lesser amount of energy to be stable. तो मेरा कहने का whole topic ये है कि if you are keeping electric dipole in external electric field, dipole will get aligned in the direction of electric. Similar thing will happen with the magnetic dipole. यहाँ पे जो मैंने magnetic material लिया है ना, inside this magnetic material, there are various atoms, and these atoms may have individual dipoles. So their dipoles are randomly oriented. Once they will face magnetic field in a certain direction, they will get aligned in a particular direction. तो इधर align हो जाएंगे, and they will generate extra electric field in this direction. क्योंकि on the axis of dipole, magnetic field किधर होगा? In the direction of dipole. So if dipoles are going to get aligned in the direction of B naught, they will generate additional magnetic field in the direction of B naught. So here magnetic field is going to increase. तो इसी को हम लोग मैग्नेटाइजेशन कहते हैं, जो कि मैं वीकडेज क्लास में पढ़ाऊंगी नेक्स्ट लेसन्स में। So B equal to क्या होगा? B naught plus Bm, that is external magnetic field plus magnetic field because of magnetization, net magnet. तो इसी मैग्नेटाइजेशन प्रोसेस को हम पढ़ते हैं थ्रू हिस्टेरेसिस कर्व। तो हिस्टेरेसिस कर्व में हमने क्या किया, जैसे यहाँ पे कर्व में देखो क्या है, हमने क्या लिया, along the x axis there is an h and along y axis there is b. What is this h? H is a magnetic intensity and h is defined as b naught by mu naught. ठीक है, so b naught means, b naught मैंने किसको बोला था, अगर याद रखो आप, इसको बोला था एक्सटर्नल मैग्नेटिक फील्ड को, तो दैट इज रिलेटेड विथ करंट, मैं ये कहना चाहती हूँ। तो कहने का मतलब, अब आप यहाँ पे आओ, व्हाट विल हैपन, this is a magnetic material, coils are wrapped like this, I'm increasing current. So suppose करो at t equal to 0 पे करंट क्या था, 0 था, करंट 0 होगा तो h भी क्या होगा, 0 होगा, है ना, क्योंकि h is b naught is what, mu naught n I. So h is related with what, current. So if I'm going to increase current, h will increase, and as h will increase, जैसे जैसे b naught increase होगा, previous अगर explanation में जाओ, जैसे जैसे external magnetic field increase होगा, more dipoles will get aligned in the direction of what, external field. तो क्या हो रहा है, जैसे जैसे तुम I को बढ़ा रहे हो, I बढ़ेगा तो क्या होगा, मैग्नेटाइजेशन की वजह से जो मैग्नेटिक फील्ड है वो भी बढ़ेगा, यानी कि नेट मैग्नेटिक फील्ड इज गोइंग टू इंक्रीज। तो हियर व्हाट इज हैपनिंग, हम लोग डायग्राम ऐसे बनाते हैं, H बढ़ रहा है बढ़ रहा है बढ़ रहा है, B भी बढ़ रहा है, एक सर्टेन पॉइंट पे B क्या हो जाता है, सैचुरेट हो जाता है। कहने का मतलब कि it has reached a point where all the dipoles are aligned in the direction of magnetic field. Beyond that, even if we are increasing H, B will not increase क्योंकि there is no other dipoles left to get aligned in the direction of magnetic field. So this is saturation. अब ये ऐसा होगा। उसके बाद if you are going to decrease the current, what will happen? यहाँ पहुंचने के बाद अगर करंट डिक्रीज करते हो तो some dipoles will start getting dismantled, start getting random, क्योंकि हम लोग B naught के वैल्यू को डिक्रीज करें। So what will happen? B will decrease, come here. But you can see here, even if I equal to 0, that is external magnetic field is 0. Even at that point, B is not 0. It means some magnetic field because of magnetization is there, and that is called retentivity. तो ये है retentivity. तो अगर जिसका retentivity high है, इसका मतलब क्या हुआ कि अगर तुमने करंट देना बंद कर दिया, after that also this is a good magnet because it has magnetic field inside. So if retentivity is higher, that will become a permanent magnet, a good magnet. Done. So that is a hi, hello, Jenny, Yanam. It is too beautiful to see everyone. Hello. मतलब after long time I get to see this setup now. This is very interesting. चलो, thank you for this. अब आप देखो यहाँ पे क्या होगा, retentivity high है. If you say retentivity is higher, तो retentivity अगर high है तो हमारा magnet भी क्या होगा, magnet will be a permanent magnet, a strong magnet. तो ये strong होगा, ठीक है, done. Electromagnet का मतलब क्या होता है, temporary magnet. मतलब to the long we are flowing current, only until then we want magnetic field inside the magnetic material. So that is a temporary magnet. In that case, retentivity should be very small. Done. अब देखो एक और टर्म है, उसको भी मैं डिस्कस कर देती हूँ, that is coercivity. तो coercivity क्या होता है? What I did here, I decreased current to 0. Now what I am going to do, I am going to flow the current in the opposite direction. Initially current was flowing in this sense. अब सपोज करो करंट को मैंने इधर से फ्लो कर दिया ऐसे, तो एक्सटर्नल मैग्नेटिक फील्ड डायरेक्शन विल चेंज, P naught is going to change in this direction. So now what will happen? अब क्या होगा बताओ? This is a bit जैसे initially when B naught was in this direction, what was happening? Dipoles were aligned in this direction. ठीक है, तो इसको ध्यान से ऐसे समझने की कोशिश करना. ऐसा कुछ डाइपोल ले लो, ठीक है. So because of B naught in this sense, its dipole were aligned in this sense, and that was generating a magnetic field Bn. ठीक है. And even at I equal to 0, that is when B naught was 0, कुछ तो डाइपोल रैंडम हो गए कुछ रैंडम हो गए, लेकिन स्टिल सम डाइपोल्स वर अलाइंड इन दिस डायरेक्शन स्टिल, एंड दैट इज व्हाई BM what not zero, है ना, कुछ ऐसा था. Now what I am doing, I am reversing B naught direction. So in this direction I am making B naught. So अब क्या होगा, again dipole has a tendency to align in the direction of magnetic field. तो जो भी dipole were aligned in this direction, initial direction of magnetic field, will start getting random and will start getting aligned in this sense. So for some moment what will happen, all the dipole will become random. All the dipole क्या हो जाएंगे, random हो जाएंगे, घटेगा घटेगा, magnetic field zero होगा, हो जाएगा. उसके बाद all the dipoles will start getting aligned in this direction. Then magnetic field will start increasing in this sense. ठीक है, वही ये कर्व ऐसे दिखाया. तो this is called coercivity. This is called coercivity. How much magnetic field in opposite direction you need to apply to make net magnetic field equal to zero. That is coercivity. Now let's come to the question. तो question में क्या था? These materials are used to make magnet for electric generator, transformer core and electromagnet core. Electromagnet means temporary magnet. मैंने बोला कि अगर temporary magnet बनाना है, retentivity should be lower. तो यहाँ पे देखो, it has high retentivity and it has a small retentivity. So this will be more good for what? Electromagnet. In transformer core, we also use temporary magnet. Again, this will be true. For electric generator, we tend to use permanent magnet. So for permanent magnet, B will be more good. है ना? तो इसको और डिटेल में तुम लोग whatever I have discussed, from that you can easily understand the topic. तो NCERT का जो magnetism and matter का chapter है, go to the last of that chapter. You will get there the discussion of this topic. So do go through those lines. अब यहाँ पे देखो कौन सा ऑप्शन करेक्ट होगा. A for electric generator and transformer. No, A can't be, this A can't be true for इलेक्ट्रिक जनरेटर एंड ट्रांसफार्मर. जनरेटर के लिए तो हो भी सकता है, बट फॉर ट्रांसफार्मर इट कांट बी ट्रू, क्योंकि फॉर ट्रांसफार्मर वी यूज इलेक्ट्रोमैग्नेट, टेम्पररी मैग्नेट. ए फॉर इलेक्ट्रोमैग्नेट कभी नहीं, क्योंकि ए हैज अ हाई रिटेंटिविटी. ए फॉर ट्रांसफार्मर बिल्कुल नहीं. बी फॉर इलेक्ट्रोमैग्नेट एंड ट्रांसफार्मर, दैट इज ट्रू. ठीक है, दैट इज ट्रू. यहाँ पे एक चीज और मैं बता दूं, समटाइम्स इट हैज बीन आस्क्ड इन द एग्जाम कि हिस्टेरेसिस लूप के अंदर का जो एरिया होता है वो क्या बताता है. तो तुम लोग बस इसको याद रखना, दैट एरिया टॉक्स अबाउट द एनर्जी लॉस ड्यूरिंग मैग्नेटाइजेशन. तो जिसकी एरिया कम होगी वहां पे एनर्जी लॉस भी कम होता है. दैट इज व्हाई दिस इज मोर गुड फॉर मेकिंग इलेक्ट्रोमैग्नेट्स. ठीक है, चलो. तो इसके काफी सारे रीजंस हैं फॉर इट टू बी, फॉर दिस कर्व टू रिप्रेजेंट इलेक्ट्रोमैग्नेट. फर्स्ट थिंग, इट्स रिटेंटिविटी इज लो, coercivity is low, and also energy loss is low. I hope it is clear. I tried. चलो अब इस क्वेश्चन को करके बताओ जल्दी से. क्वेश्चन इज वेरी इजी. टेक सम 2 minutes and do it. You have studied SHM for electric dipole, right? Same thing you need to apply here. If you have not studied it, let me know through the chat section. Instead of waiting, I will explain it. After that, you will do it. If you have learned it already, then try to do it. Even if approximately you are getting, you can tell me, क्योंकि B and D option seems quite closer, A and C quite closer. Still, let me know you are getting nearby 6 or nearby 8, or I must say nearby 9 or nearby 7. नहीं आ रहा किसी का? ओके, JNB सोनितपुर, yes, it seems correct. Very good. Others, please. Sorry. प्रेम लोखंडे, बाबू साहब कुमार, वाह क्या नाम, क्या चल रहा है? गुड मॉर्निंग, हाय, आई नीड आंसर्स. हाय, हेलो, गुड मॉर्निंग, गुड आफ्टरनून, व्हाटएवर, बट गिव मी आंसर्स. अदर्स प्लीज. देखो सिंपल चीज है, इफ यू डोंट रिमेम्बर देन आई एम जस्ट taking you through the memory lane. So in electric dipole, or just now I discussed, let's take magnetic dipole itself. I said if there is an electric field, magnetic field present, and if there is electric dipole here, so naturally electric dipole will align in which direction? In the direction of magnetic field, if this is magnetic dipole. Now what is going to happen if we are going to disturb it? सपोज कर लो ये रेस्ट में है, naturally it will be along the direction of B field. Now if what I'm going to do is I'm going to disturb it, I'm going to move it by an angle theta. So what will happen now if I'm going to move it by angle theta? What will happen now? Now their torque will act here, है ना, और वो torque इस तरह से लगेगा कि it will try to bring it back to this position. That is, if I have moved it in anti-clockwise, then torque will act in the clockwise direction. You can check it also. So tau को क्या लिखोगे? Again, torque का value क्या होता है for dipole thing? That is m cross p, right? That is what? M cross p. Now here m cross p. Tau को क्या लिखोगे आप? mb sin theta. Suppose कर लो theta is very small, by very small angle I have moved, then in that case tau will be what? mb theta, क्योंकि sin theta can be taken as theta. Now just now I said if theta is in anti-clockwise direction, tau will be in clockwise direction. So negative sign here, क्योंकि direction of theta and tau are opposite. So tau को क्या लिखोगे? I alpha minus mb theta. These are things of class 11th, लेकिन हमें formula से मतलब है फिलहाल. So alpha can be written as minus nb by I theta. So this is nothing but what? This is omega square. Omega square is how much? mb by I. So omega is equal to what? mb by I. Remember this. This is magnetic dipole moment. This is magnetic field. This is moment of inertia, right? So moment of inertia for magnetic dipole around center, just consider it like a rod. So it will be how much? ml square by 12, where m is the mass. Okay. So just put this thing. क्या लिखोगे यहाँ पे? Time period क्या लिखोगे? 2 pi by omega. So 2 pi root under ओमेगा का वैल्यू कितना आया था? ओमेगा वाज mb by I root over. So 1 by omega कितना होगा? I by mb. Put it here. ठीक है. Now just put the values. 2 pi root under I का वैल्यू क्या दिया हुआ है? That is given as 7.5 into 10 to the power minus 6 divided by how much? 6.7. That is dipole moment. 10 to the power minus 2 into magnetic field 0.01. Something like that. And if you're going to solve it, this will be 2 pi into 7.5 by 6.7. It will be 1.1 something around. And if you're going to write this, so it will be 1.1 into 10 to the power minus 6 है, minus 2 है, minus 4 होगा. ये भी minus 2 है, 10 to the power minus 2. So overall 10 to the power minus 2 you are going to get here. है ना? So 2 pi into root over 1.1 का वैल्यू कितना होगा? Almost 1.005 के अराउंड होगा. So 1.005 into 10 to the power minus 1. Now if you're going to solve it, so this is 3.14, 6.28 into 1.005 into 10 to the power minus. So how much value for 10 oscillation निकालना है? तो 10t निकालना है तुम्हें. t का वैल्यू ये है, तो 10t करोगे तो ये चला जाएगा. So overall answer will be something 6.65 के around. So D will be your correct answer. Done. I hope it is clear. चलो, so सारे formulas को याद रखना. जो भी question we are dealing, I am also giving you the explanation. So have everything in your head. कुछ भी भूलना नहीं. Do this question. This is the last one. So take some 2 minutes of your time. You don't need this much, but still I am giving. Let me know. If you remember the formula here, you will be able to do it within minutes. But if you don't, then क्या ही बोलूं? If you don't remember formula, let me give you. है ना? अभी मैंने बताया था. If there is the magnetic material inside solenoid and then we are flowing current through it, so net magnetic field was B naught plus Bm. B naught is external magnetic field. Bm is magnetic field because of magnetization. B naught को क्या लिखोगे? Mu naught H, क्योंकि मैंने define किया था H equal to B by mu naught. B naught by mu naught. बोला था ना? So this is this. Bm को क्या लिखते हैं? इसको लिखते हैं mu naught m, where m is what? M is not dipole moment simply. It is magnetization. And magnetization is defined as what? Magnetic dipole moment per unit volume. So this is this. तो इस क्वेश्चन हमारा इस पार्ट से है ना? So mu naught m can be written as what? That is your Bm. Then this is this. And M can be written as magnetization is related with H. Just now we have seen it was related with H, and that is equal to chi H, where chi is magnetic susceptibility. So here you have to calculate chi. Here what is given? A paramagnetic substance in the form of a cube. Cube is given. Side कितना है? 1 centimeter. इसकी magnetic dipole moment कितनी है? 20 into this. So magnetic dipole moment is given. But magnetization is what? Magnetic dipole moment per unit volume. Volume is also given. तो per unit volume निकाल सकते हो, है ना? Magnetic intensity, that is H का value is given. So calculate chi. So let me know answers now. You also need to do hard work. मैं पहले बता रही हूँ, कुछ लोगों को लग रहा होगा क्या चल रहा है, but let me tell you, जो भी चल रहा है वो already तुम लोग के क्लास में चल चुका है. So you just need to be sincere and honest with your lessons. Done? अपने तरफ से तो कोशिश करो. It may be like कि you need something more, ठीक है, but you should put effort as much as you can. There should be no miss in that. तो आंसर्स बताओ जल्दी से क्या होगा. एम को लिखो मैग्नेटिक डाइपोल मोमेंट पर यूनिट वॉल्यूम. डाइपोल मोमेंट दिया हुआ है ना 20 into 10 to the power -6 डिवाइडेड बाय पर यूनिट वॉल्यूम करोगे तो कितना होगा? 1 सेंटीमीटर का होल क्यूब यानी कि 10 to the power -6 का ही. एच का वैल्यू कितना है? 6 into 10 to the power 4. यही है ना? हाँ, अब आप यहाँ से निकाल लो काई का वैल्यू कितना आ रहा है. चलो आई गॉट वन आंसर. चेनवी सोनितपुर. सिंस इनकरेक्ट, आई डोंट नो. एक सेकेंड मैं भी देख लेती हूँ. काई इक्वल टू कितना होगा बताओ. इट विल बी 20/6 into 10 to the power 4. इसको ऊपर लेकर जाओगे, एक 10 कैंसिल होगा. 2/6 into 10 to the power -3. If you're going to solve it, it will be 0.33 into 10 to the power -3. ठीक है. And if you're going to solve it further, so it will be 3.3 into 10 to the power -4. So correct answer should be what? Correct answer should not be B, it should be A. 10 के पावर में कुछ मिस्टेक किया था आपने, है ना? Is it clear now? I guess A is the correct option. Yeah, A is the correct answer. ठीक है. There are some more questions attached as homework, so that I will give in your notes. Notes कहाँ मिलेगा? Description में link है, वहाँ पे मिल जाएगा. YouTube वीडियो के description में, right? तो चलो, take care everyone. Stay safe, stay healthy, keep reading and keep being honest and sincere. सबसे पहली चीज ये बहुत जरूरी है. Honesty खुद के साथ करो, दूसरे का क्या करना. Be honest with yourself. That is the best you can do. Okay. चलो, bye bye. Take care.